tenuous envelope of gas surrounding our planet is an unbelievably complex machine that protects us from the vacuum of space, shelters us from harmful radiation, and allows us and the biosphere to breathe. It is our atmosphere, and we need to learn much more about it so we can take better care of it. Soon the European Space Agency ESA will launch its new Earth observation satellite called AEOLUS. Using cutting-edge laser technology, AEOLUS will provide near real-time observations of wind profiles across the globe. These will improve the accuracy of numerical weather prediction and climate modeling, and advance our understanding of global atmospheric dynamics.
AEOLUS is one of the Earth explorers that is going to look at the Earth, trying to understand the wind profiles globally. And that's a first, it doesn't exist yet. The whole idea was that we only have wind measurements on very different small spots on the Earth, and we didn't have it globally. So the mission scientists had been asking for this because it's a gap in our measurement system.
The mission aims to expand our knowledge of our atmosphere and weather systems. AEOLUS will achieve this by providing global observations of wind profiles from space, providing data which has never been available before.
It's unknown ground, it's what we call uncharted territory. So we are the first agency trying to get a satellite in orbit that looks at the Earth with a laser and trying to understand the wind profile, so the direction, the height and the wind speed. And therefore improving the weather forecast. Because nowadays we only have at single points balloons that measure the wind, or airplanes that give us some data, or at fixed points, at discrete points. This will look down to the Earth in a polar orbit, will dump every 90 minutes the data to Svalbard. That will be distributed to all the European meteorological institutes. And then when you're sitting at home on your couch, you watch the television and you see a weather forecast that is much better than we have it today.
AEOLUS will fly in a sun-synchronized polar orbit 320 kilometers above Earth's surface. Its data will be sent to ESA's Svalbard ground station, located in the archipelago halfway between Norway and the North Pole, every 90 minutes. The satellite's main instrument is Aladdin.
Yes, the way the Aladdin instrument works is to eject an ultraviolet beam down through the atmosphere, and then particles of moisture in the atmosphere at various levels are in motion because of the wind, and the system measures the backscatter from those particles using the Doppler effect and can detect the wind speed at the various altitudes, and that's the way the system operates.
The development of AEOLUS has been a long and difficult process, with new and cutting-edge technologies designed, developed and tested on the ground.
It has been a very difficult challenge, let's say. It's a long life, because it exists already for 16 years, the program. And when we first had the part of the instrument, when we switched it on, it worked. Then we put it in vacuum and it stopped working. And no one had realized that we needed oxygen inside the satellite to keep the laser active. So it was quite a challenge, so we had to develop a whole new set of techniques. It's maybe a bit too detailed to go in all the details, but as a lot of technology has been developed, put in this nice little satellite which is behind me.
AEOLUS is another ESA Earth Explorer mission aimed at pioneering new technology while providing useful data about our ecosystem. It showcases the technological expertise of the European space industry and ESA's objective of monitoring and understanding the planet we all live on.
The main challenge for us has been within the development of the Aladdin instrument. There's a very high-powered ultraviolet laser system in there that is an inherent part of the instrument. And the technology behind that laser system, the development of a stable laser, high-powered laser beam, and the optics that then focus and divert that beam through the system is very critical, and that's been a very key part of the development. After many years and much hard work across the European industry, we've overcome those problems. We've got some new development through coating technology on the optical surfaces to protect them. And we've now got a stable system that's been fully tested on the ground, and we're ready to go.
The tracking of air pollution is also part of the European Union's Earth observation program, Copernicus, one of the satellites that gave scientists massive amounts of data on atmospheric pollution was ENVISAT. This satellite used several spectrometers to detect ozone and trace gases in our atmosphere. The latest satellite, the Sentinel-5 precursor mission, was recently launched and builds on that legacy of ENVISAT.
So we started this precursor mission because the scientists wanted continuity of data. At the moment we only have one spacecraft doing that job for us, which is OMI, and OMI is coming towards the end of its lifetime. The next missions that will do this job is Sentinel-4 on metapsych generation, which will only be launched in early 20s. In the meantime, to ensure a continuity of data, we need Sentinel-5 precursor. It will be the only such mission doing this job until then.
Sentinel-5B is a precursor to the Sentinel-5 mission, which should be launched around 2021. But it's not only a precursor, it's also a gap filler, because it's filling the gap based on the data that we have coming from Gomez, Kirmaki and OMI measurements towards this future Sentinel-4 and Sentinel-5 missions.
Sentinel-5P is the first atmospheric chemistry mission within Copernicus. Its main instrument is a state-of-the-art spectrometer called TROPOMI, which will be used to detect trace gases in our atmosphere. With Sentinel-5P and TROPOMI, Copernicus will dramatically improve operational atmospheric services. The Sentinel-5P satellite is a timely replacement for the ERS and ENVISAT after it stopped working. There was an urgent need to fill the gap in observing air quality and air pollution. Furthermore, according to the World Health Organization, air pollution is responsible for over 3.7 million premature deaths worldwide every year. But the health costs are even greater, as many people suffer from non-lethal afflictions either caused or aggravated by breathing polluted air. Another major health concern on which Sentinel-5P is gathering data is the ozone in our atmosphere. When that ozone is depleted, ultraviolet light from the sun is no longer filtered. Increased exposure to UV light can cause skin cancer, immune system damage, and other ailments in humans.
The TROPOMI data will be used operationally, so it will be used to improve the air quality forecasts. And air quality forecasts are of course important for people who are vulnerable to pollution, but also for the general public in case of big smog events. What we can do with the TROPOMI data is we can look at the emissions of pollutants. And when you see them changing over time, that is very important, because we can see if certain policy measures have the right impact, or where we see still increases and still have to do more to reduce the polluting emissions.
A decline in air quality, such as smog, poses massive risks for people's health. And one of the main contributors to climate change is the pollution of our atmosphere by greenhouse gases such as CO2 and methane. This is why measurements on air pollution need to be undertaken everywhere. Like here, for instance, with a mobile measurement station at the University of Bremen. It detect smog and industrial emissions. These local measurements supplement and validate the global observations from satellites, which in turn are needed for scientists to study the air we breathe and the planet we live on.
Well, the satellites are a key information base and knowledge base for the study of atmospheric physics, chemistry and meteorology. It's essential data because we need to know not just what's coming out at a given place, but we need to know where it's going, where it's depositing at the surface, how it's being transformed, is it going to be taken up by clouds and rained out, if so, where? And this whole transport and transformation process is a complex business. In general, we have this problem of unambiguously identifying anthropogenic impact from natural phenomena or natural behavior in this complex system and how we're modifying it. So this is the challenge for the science, which is a necessary prerequisite to enable good legislation and ultimately sustainable development. So in this context, measurements from space are essential because they provide us with the global picture or from the local to the global scale.
The Sentinel-5P mission will have quite some improvements as compared to previous missions. For example, if we look at the spatial resolution, we will break a record, namely we will look at city scale because the nadir pixel size will be as low as 3.5 kilometers times 7 kilometers. So we can then investigate small-scale features over big cities and city agglomerates, for example.
The mission will monitor the atmosphere using the tropomi spectrometer to monitor various trace gases in our atmosphere and reduce data gaps between ENVISAT and Sentinel-5. By combining satellite data with the local measurements on the ground, scientists can properly monitor air pollution and how it impacts us and our planet.
We have lots to understand to assess the impact. Ultimately, more pollution is bad for health, bad for people, and the estimates are somewhere between 3 and 7 million people a year die prematurely from air pollution. This is a large number of people.
At the forefront of Earth observation, the European Space Agency helps us to understand climate change and pollution by giving scientists and policymakers the data that can drive legislation.
These atmospheric measurements are extremely important for mankind. First of all, to see how our planet changes in terms of climate, but also to see how air quality changes in different places and over time. We have highly polluted areas which are, of course, transporting pollution from one place to the other. So these fluxes of pollution or gases is very important to monitor. But also, if you take Europe, for example, Europe has introduced very strong legislation and regulations in order to reduce greenhouse gas emissions. And this has also to be verified, and these satellites are a very good measure or very good way of making sure that these reductions are taking place at a large scale.
In the early 2020s, the space component of the Copernicus atmospheric services will be extended through the addition of Sentinel-4 and 5 missions. Sentinel-4 will be a geostationary mission, whereas Sentinel-5 will be a low polar orbiting mission like Sentinel-5P. Atmospheric services are part of the Copernicus portfolio, which comprises 6 main themes: marine, land, emergency, security, climate, and atmosphere, giving a complete overview of our planet's health and its evolutions.
Can have a lot of practical applications using the data from the Sentinel-5P mission. One idea would be perhaps if we look at the harmful UV radiation, you could set up UV radiation services so that people on the street so to speak, in the sun like today, could inform themselves how harmful it is to receive this short-wave ultraviolet radiation.
The Sentinel-5 precursor data will be combined with models and other data to develop targeted services, and they will be available as apps, social media information or web services, so that a lot of people can choose their way they want to be informed about the environment.
Atmospheric measurements are important because especially these measurements that are done by Sentinel-5 precursor, like tropospheric ozone, information about nitrogen dioxide, sulfur dioxide, also information about aerosols, particulate matter, they have impact on the health of people. They can impact the people who have problems with their hearts or with their lungs. And as it has been shown, there are more than 400,000 premature deaths in the European commissioning based on exposure to air pollution.
Air quality in Europe in particular, but also in the US and in Japan, got much better over the last years. That's a really big improvement. And at the same time, air quality in the developing countries, in particular in Asia, has gotten worse because they use much more energy nowadays, and that's a big source of air pollution. Also, if they are using more cars, that will pollute the air more. So it's different, depends on where you live. In some places air quality gets better, in other places air quality gets worse. I should add that in the last 3 years air quality in China has improved because they are very ambitious about that and have very strict rules. So they are trying to follow the European or United States path in improving air quality with better technology.
Observation from space is just one of several methods of measuring atmospheric pollution. Satellites provide the data, although they need to be calibrated with measurements on the ground.
So we are offering a comprehensive analysis, integrating data at different scales. So we are using observations, we are combined with modeling, with satellite data, and all this information is complementing each other. This is the good thing of this kind of analysis. Satellite have the advantage of providing a global picture. Trends, you can study trends very well, how the main flows are taking place. But satellite data, they don't have the resolution to get in detail in the individual processes. So here, with our in situ measurements, we are getting in one particular point, and we get deeply in the detail.
The satellite gives these beautiful maps, but you can only use them really if you have a validation measurement to compare to, and this needs to be a very good measurement, and this needs to be taken on the ground. That's very important for us because we need to be very confident of the satellite data. And once you have launched a satellite, it's out of your hands and you cannot bring it to the lab and double check and test it. It's there and you need to trust the data, and the only way to get this confidence in the data is by comparison to other measurements.
Other forms of atmospheric pollution, such as the exhausting of carbon dioxide, methane and ozone, contribute greatly to climate change.
Well, I think basically it's often the case that our models, which are extremely complex and good tools, often don't necessarily have the right physics or chemistry in them to be able to predict what's going on in the future. So a lot of the time in atmospheric science we've been making discoveries. Back in the late 19th century, early 20th century, the discovery of the stratosphere was a complete surprise at the time, or fairly surprising. The fact that temperature increases above the above the tropopause. This was a surprising discovery, and really that's been typical. We didn't expect summer smog. We don't understand why in Paris there was a really big smog a couple of years ago in spite of improvements of legislation. This winter we had in London a smog which is maybe being attributed to excessive wood burning recently. So there's a lot of things although we're getting over the last 25 years much better information, but the satellites in particular tell us ultimately, or could tell us ultimately, what the source strengths are and enable us to follow the information and thereby, together with models, give really good prediction for people about the air quality that they're receiving.
The Copernicus program is very important for Europe and for the world. First of all, the Copernicus program is providing free data to everyone at any place in the world. So many users, not only in Europe, but also in America, in Asia, are using our data in a very large scale and very significantly. So therefore, Copernicus is really monitoring the health of our planet from all dimensions: the atmosphere, the oceans, the land surface, the ice caps, and this whole system of the Earth composed of these components is monitored constantly with Copernicus. And therefore it is really important to see what is the state of our planet and how it will evolve in the future.
Well, the data can be used for different applications. So for example, for the air quality forecasts. It's also used by KNMI, for example, for the UV forecasts. And we also use it to warn the aviation for volcanic ash plumes. On top of that, the data will also be used by scientists around the world to study the atmosphere and to study how man is changing the atmosphere over time. Continuous monitoring is very important, especially when you're looking at slow changes, and an overlap between the data is then really necessary to be able to glue these different data sets together to one data record. And we have data records from these kind of instruments starting in the 19s, for example, for the pollution. It's very important to maintain these valuable data records and to extend them into the future.
Well, the data is important for our climate research and also for our environment, because the air we breathe, it could be changed due to all sorts of pollution events. And then a second example is that we need to monitor our ozone layer. Since ozone is destroyed due to chlorofluorocarbons, Sentinel-5P will have also the role to monitor the further evolution of the ozone layer.
Mankind can halt the pollution of our atmosphere with good legislation. The European Space Agency, ESA, works tirelessly to monitor our planet and the air we breathe.
We need a future where we, with so many people on the Earth, are in a position to maintain a good quality of living for human beings, but also for the biosphere.